Hello guys, you're welcome to StaadPro. In today's class, we'll be discussing site grading drawing or site grading plan. I'm going to discuss and explain how I was able to create this site grading plan. So I have 5 sheets. I'm going to go through all these 5 sheets. I'll walk you through all the 5 sheets and explain everything that is necessary in this site grading plan. So this is sheet 1. I have sheet 2, then sheet 3 is there, 4 and 5. So all these are going to be explained in this video, so I urge you to stay tuned to the end. And I'm going to actually show you one special thing. Not everybody knows how to faint drawings like this. So if you see this plot plan I superimposed in this site grading, is very faint. I can even make it more faint, so but I'm going to show you that at the end of this video. Watch till the end for you to see this particular lesson. To get this particular lesson, I have to make a drawing very faint. So I'm going to explain all this. Like I said before, I like keeping my drawings in paper space, where the paper will be the actual paper size. What this paper here is actually, if it is A3, is actually A3. If you dimension it, you are going to get 450 by 297. So again, I'm going to give you the link to download this drawing in case you need it, because every civil engineer will need template. So we need template for your future design. So if you have a site grading drawing plan to create in any of your projects, once you pick up this one, you already know what to do. Just replicate, and if you want to even match properties, you can match property like this faint. Like you want to fit any object, you can match properties. So I'm going to drop the link of this drawing in the description of this video, so that you can quickly download it for your use in the future. Okay, so before I continue, I will beg you, if you are still enjoying my content and you are here to subscribe, please subscribe and also click on the bell button, so that whenever I post a video, you'll be one of the first persons that will get notified for the post. I also like you to give me a thumbs up, give me a like also. So these are the things that will make YouTube know that people are actually watching the content, and they will keep suggesting my video to more engineers. So please just help me, give me a thumbs up, so that my video can move. So okay, so let me just dive into the business of the day. I like to work in model space. This is what is called model space. So but my drawing is always kept in the paper space. So let me just go to model space to explain. So the first sheet is actually this, showing the whole plot acquired by the client, as I explained in our last class during plot plan design. So this is the whole plan, the whole area that the client procured, but we are actually utilizing the some portion of it inside, where I superimpose my plot plan. So I have blocked this plot plan actually, so that I can easily remove it from here if I want to, or bring it in if I want to. So I will also show you how to block drawings, because this one is AutoCAD classes as well. So the first thing to do actually in site grading drawing is to go for a site visit. Yes, it is good to request for a site visit, so that you can put a picture to what the topographical guys have done. Like I told us in the last class, this drawing here is topographical drawing, so that it has the spot height and the contours of the site. From this drawing, one could tell, whether the place is a flat land, or it has some hilly portion or so. But you cannot tell if the place is prone to flooding, or if there is a river somewhere where you can channel your water. So when you are preparing your checklist for your site visit, because each site visit has what we call checklist. So for you to prepare checklists are those things you need to check at site. So if you are going for this kind of site visit, you need to prepare a checklist, which inside the checklist you are going to put, number one is going to be to check the accessibility of the plan. Does it have access to road? Okay, if the answer is yes, okay, does the access road have drainage? Because it is going to be very, very important for us to be able to channel our drain water. For if it doesn't have drainage, is there any possible drainage outfall? Is there any river around, or a canal or channel around, where we can put channel our water. So that's supposed to be part of the checklist. Okay. So another one is the place prone to flooding. If you look at the place, you can ask the people that are living around whether if anytime rain falls, whether the whole place used to be flooded. So that's very important question. So, but in this particular design, when I went to the site visit, I was able to communicate with the client. The client walked me around, and I asked the client a lot of questions. So he told me that the place is prone to flooding. So each time there is a heavy rain, the whole place used to be flooded. So that suggests to me that I need to raise the site up. Okay, so if you observe this spot height, so you will know the level. So the first thing to do is to determine your design level. What is your design level? So that design level is what I called site preparation level. So you're going to build up the area to a particular level. That's the site preparation level. So the spot height is what we call the um, 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 natural ground level. So these are the spot height, natural ground level. So now if you look at this spot height like we examined the last time, this is 13.6, 13.6. So towards the middle we have 14.2. So this place is lower than this place. So we have 14.2 within the plot, 14.0. Okay, so this 13.6 has come down again. So this somewhere here is high. So I now used 14.76 as my design level. So thereby raising the site up to about 500 mm or 550, average of 550. Okay, so this value here, this 14.76 should be the highest value here. All the spot height here should be lower than this. That's to tell that the site is being raised up by about 550 mm. If you do the subtraction, if you get the average value of this spot height, subtract it from here, you'll get a difference of 500 mm or 550 mm or thereabout. So this is what I will use as my site preparation level, which means that they are going to import sharp sand, because sharp sand is what I recommended. They are going to import sharp sand to this area and raise it up. So as they are bringing the sharp sand, they are supposed to be compacting them. I also recommended the compaction density, so they must achieve that during compaction so that the place will be very strong after preparation. So that is it. So I have established my site preparation level, which is 14.76. So we have finished grade level, because when you finish filling the site, so and you have done your foundations, you can still um do some designs on top. You can bring in some anti-weed and chippings to still completely finish the surface. So that's the finished grade level. If you look at this, and the difference should be about 75 mm. So the finished grade level is also what you can call datum. In terms of when you are doing your foundation designs, you can just use datum to show finished grade level. You get, so from that datum is 00. If your building is 3 meters, you can begin to count from 00 to 3 meters, so everybody understands what you're talking about. So all the design drawings and foundations, we reference this datum to speak to the finished grade level. This is very important. So when all these are determined, the next thing to do is to bring in the plot plan which I've produced. We are going to bring in the plot plan which I've already done. You get, to just copy the plot plan from where it is and bring it to this place and block the plot plan. The next thing is to determine the area of cut and fill. So in this particular case, I have everywhere is going to be filled because I'm raising the site up by 500 or 550 mm. You get, so it means we are going to fill the whole plot. So but in case in your own work, if you have a reason to cut anywhere, like for example, if this region is very high, maybe I have a spot height of 15.0 at this area and these other ones are low, it means that we are going to cut this place down to to 14.76, from 15.0 to 14.76, while this other region that is lower will be filled up to 14.76. So that takes me to the next action point, which is calculating the volume of fill. You understand? So you need to calculate volume of cut and fill. So if you have cut in your own, you need to calculate the volume. If you also have fill in your own, you have to also calculate the volume of fill. So now if you come to the paper space, okay, from here you can see that I hashed this whole plot because I want to represent the filling with this hash, you get. And if you go to my paper space sheet 1, you will see where I wanted to show us our legend, but I think the legend is in sheet 2. Yes, this is sheet 2. So legend is in sheet 2, okay, because sheet 2 is clearer. So now this hash pattern depicts the area of fill. So for my own this particular project, everywhere is filled up. So that's what it shows here. So you have to also represent where you have cut and where you have fill. So if you have cut in some area, use a different hatch pattern to show the cut area, then use another different hatch pattern to show the fill area. But in this particular case, we only have fill in all over the place. So now for us to calculate the volume of fill, is very simple. We just command area in our AutoCAD to get the area of this plot. Okay, get the area of this plot. So let me just demonstrate that. I will just type area the keyboard, then I will select okay, before that you can offset 1 meter away from the plot so that you get 1 meter away from the plot. So it's not just the area where you have the plot plan you're going to fill like 1 meter beyond the plot plan, you get. So we can do offset 1 meter. I don't want to do that. You can do one offset of 1 meter away from the fence line, then you now use that as your boundary to get the area of fill. So I will just get my own area like this, area of fill, do something like this. Press enter. So when you do that, you see area is this in meters and this is perimeter. So now for us to get volume of fill, so this is area, we need to now multiply it by the average depth. So what is the average depth? We need to calculate the average depth. That is the difference between the average spot height and the design level. So when you do that, you will get about 0.5 or 0.65 or 0.7, as the case may be. So you multiply this area with that depth, that will give you volume. So what I have here after my calculation is 14.4 square meters. So sorry, this is supposed to be volume. It's not supposed to be square meters, it's supposed to be cubic meters. Sorry, cubic meters. It's supposed to be cubic meters. The value is correct, but the unit is not correct. Okay, so cubic meters, that's what it's supposed to be. So I will just correct that now. So that is just the first page. So we now go to the second page, which is this. So here in the second page, you're going to now show sections. We're going to cut section, transverse and the longitudinal. Is very, very important. So we have longitudinal section, which is section B, and we have a transverse section, which is section A. Okay, so we're now going to show these sections. So this section is going to show us how the natural ground level is in relation to the design level. You understand? So that is that. So what I will now show here in sheet 2 is just the plot plan, sorry, the side grading area with the section. You get, so section A and section B. So the third sheet will be on the section details. So I'm just going to explain to us what we have here. The section details we have here. So what we need to do first is to choose our scale. So what's the scale of the drawing? Okay, so the scale for this profile is horizontal is 1:1. So I have horizontal here 1:1, which means I have 10 from here to here. This is supposed to be 0 0 from 005 to this place. Okay, so this is 0 0. This is my origin. Yeah, this is my origin. The origin is here. Okay, so this origin is where I have my block fence exactly. So now this is 0 0. That's the chainage. So this place is cumulative chainage. You have 0 0. From here to here is 0 5. That means it's 5 meters. Okay, and from there to there is another 5 meters. So if you dimension from here to here, we'll be getting 5 meters. And if you also dimension from here to here, we will get 5 meters as well. Okay, so that means our scale for our horizontal scale is 1:1. We are using 1 meter to 1 unit. That's what it means here. So we now have the changes from here to down, which is 130 meters. That's for cumulative change. So the second one is 0.3 meter removable soil before filling. So now it is advisable that before you start any construction, before you start bringing in sharp sand, you need to remove all the topsoil. Remove all the topsoil, the vegetation soil on the surface to about 0.3 mm. That's 300. Sometimes it's 150. You know. So when you remove the topsoil, then you now begin to bring in sharp sand. You know, that will fill it. So when you remove 0.3 from the site, from the ground level, you'll be having different spot height. Okay, so but this ground elevation is the natural ground level. So you have to. This is where I normally, push. You can push this section very close to the plan, just for you to get the accurate spot height at every point. Okay, so this one is the fence line. The fence line. Okay, and my fence line is somewhere here. So we can just move to align with the fence line. Align with the first line. This is fence line. Okay, line with the fence line. That's good. So I need to now be bringing down the spot height, along this line that I'm cutting in the table. You get. Okay, so you now see this one is 14.6, 14.64. Close to the fence line. Okay, so this is the fence line, 14.64. There should be a spot height here, but this one is what is close. I know I've deleted some of the spot height because it's looking clustered, so but if I check this one now, that's 14 point that particular value will be here. So you will just be picking these values that corresponds with the line that corresponds with the vertical line you are drawing. So you'll be using this vertical line to trace this spot height. Okay, to trace the spot height. You get, so any spotter that this line cuts is what you're going to bring down here. So when you are done with this, you can still move it to the second line. You get, so this one is 14.27. You still go up to where it cuts this line. So this is 14.27. So we bring it down to this place. You still move it again to the next line, 14.3, 14.23. okay, like that. So this is okay, like even if I have values, it falls in between two values. If it's not touching any of them, I can just add up the two and get the average, so, and I will bring it down here. So this is how this ground elevation is being populated, so it's simply you can also continue this line to this point, so it will be clear for you. So when you take this line up, it's going to intersect with this one, so you know where a which spot height to pick. That's how to populate this natural natural ground level. So the other one is site preparation level. So you now put the design level there. So it's going to be equal or true, since I'm using the same level for the design level 14.76, 14.76. So it's going to be like that. Okay. So the other one is the finished grade level, when you now add 750. Okay. So when that 750 comes in, the site is going to still be further elevated, so it's going to be equal or true as well, because it's the same thing everywhere. So this one is ground reference. So like I'm starting from block fence. After the block fence, you have perimeter drain. Of course, if you see here, you have perimeter drain. So after the perimeter drain, you have internal road. So if you trace this place off, it's going to hit the internal road. Looking at what was cut, internal road. So after internal road, we have office area before internal road, which is how it is there, office area, internal road. Then after that, we have a cellar slab. So if you trace it up, you're going to see cellar slab. It was cut. Then after cellar slab, you have area for mud pump. Area for mud tanks. So okay, see, area for mud tanks was also cut. Then you have the waste pit is also cut. Internal road again. Then you have a perimeter drain and block fence. So this is very 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 important as well. So for the vertical scales are also 1:1. So which means we are going to plot this. That's where the profiling it comes in. So we are going to choose our scale, which is 1:1. So starting from 13, this one is 15. So in between this and this, which is this, is 14, right? So we are going to be plotting this value. So this is 14.48. So I'll simply this is 14. I'll just simply offset 0.48, which will give you somewhere here. You get offset 0.48. You get. So what I will do is I will just use a line to mark the point. Okay, I will mark the point and I will delete this. So that's the starting point. That's the ground level at this point. Okay, so the second one is natural ground level is 14.64. So that means I will start from 14 and offset 0.64. So this is 14. Sorry, this is 14. I will offset 0.64. Okay, so that's that. Okay, so what I'm supposed to extend it to the next line. Okay, so that's that place. So I can copy this line and put it here. So this is what it is. So that's how we are going to plot all these values. So when you finish plotting it, you will now use a polyline to connect those points you plotted, and that's going to give us the natural ground level curve. This natural ground level curve, this is it. It's going to give us this curve. It's not going to be straight. It shows us how the site is, how the site is actually. This is what it is. So now if you have set 0.3 down, offset 0.3, because I'm using scale 1:1, That's why I'm offsetting what exactly what it is. Okay, so 0.3 down, we're going to get to that excavation. Get so the excavation is this. So the place is going to be excavated. The 0.3, I think is 0.25. I think it's 0.25 actually that I use, but anything can be used. This is 0.25. It's not 0.3, so I need to change it here. So this is not correct. Okay, I need to change it here. 0.3 what? It's not now because I've moved this. As I've moved it away, it's no longer in my paper space. It must have left. So I need to do undo so that I can bring them back before I will edit it. Okay, so that is it. It's not difficult. So this one shows the extent the site is going to be excavated to remove the topsoil. So before we can now start bringing in the filling material. So now the design level is this green line. So how do you get that? So we have our design, which is site preparation level as a 14.76. So we just offset 0.76 from this middle. So you can see is before 15. So this is the design level. Design level is this one. So the finished grade level is this one, which is the difference between the two is 0.75. 0.075. You understand? So this is the design level, while this is the finished grade level, or ground level rather. So this is just how to prepare this profile. So if you know how to use Civil 3D, Civil 3D can actually give you this profiling you get, but it will not give you the section detail that I will show you in the last page. Okay, if you know you have gotten value so far in this class, I will still beg you to subscribe to my channel. Please like this video. I'm begging you to just give me a thumbs up. I beg, just give me a thumbs up. It's not easy. What I'm doing here is not easy. Encourage me with your like. They're not going to charge you for that. Just give me a thumbs up. Then share this content, share this video, send it to anybody that you think we get value from it. That somebody, anybody you think it will favor, just send this video to the person. Okay, so let's continue. So this is basically how to create um, this profile. So in case you think I've not done justice to this course, just write it down in the comment section. Tell me what exactly you want me to explain further. So I will definitely do that. I will definitely do maybe a separate video to make sure that I water down your concern effectively. So that is that. So what we did here is exactly what I'm going to also do here. But this time around, what I normally do is, if you look at this plot plan, is this particular site location or site drawing is in the proper, proper direction. Okay, so but for me to actually get this, I need to rotate the site, to align with the way I want my profile to appear. So if you look at this, you see that I rotated it. Is it clockwise or is clockwise? Is anti-clockwise? Yeah, in anti-clockwise, so that from my left to right, I will have this my profile this way. So the same thing we did for the other profile is what we are going to also do here. Are you getting me? So from fence line, trace it up to where it calls this line. You're going to pick the spot height that is there. What I'm seeing here is 14.14. Okay, if you come here, you're going to see 14.14. So the same thing. So you trace it up, but first of all, make sure that your profile aligns with the drawing. So the fence line is where it's supposed to be. Start from the beginning to the end. You understand? Before you begin to trace this line and start bringing down the spot height. So when you are done bringing down the spot height, you can if you subtract 0.25 from this, you should get this. 0.25 from this, you should get this. So that's how all these values were gotten. Subtract the excavated topsoil, you will get this. Okay. Then the other one is site preparation level, which we have determined on sheet 1. We just bring in that one. It's going to be uniform all through. You get. Then the finished grade level is also the same all through. Then you put ground reference. Anything your line is cutting, you are going to bring them down and label them, put their names accordingly. Okay. Okay, so if you look at this long places, area for mud tank, you have area for mud tank because it's this whole area. So this is just a very simple drawing. So now we have details we need to show. This is detail 1, and this is what we call cross-referencing actually. So you cross-reference for easy reading and interpretation of drawings. So what does it do? This thing means that this is my detail 1 and you're going to see it in sheet 5. Yes, that is what it means. So if you go to sheet 5, I will also cross-reference it. Okay, if you go to sheet 5, this is detail 1 and you're going to see where I cut it in sheet 3. So if you go to sheet 3, you will see where I cut my detail 1. So that is just the beauty of cross-referencing. So instead of me to start looking for where detail 1 is being cut, I have already known from here. So I will just simply go directly to sheet 3 and I will see that, okay, this is where they cut detail 1. They're actually trying to show me what is happening here in that sheet 5. Okay, so that's that. So I'm done with the profiles. So the last sheet is about these details. So it's necessary to show how this area is. Because this scale is 1:1, we are not actually seeing clearly how this area is being arranged, and the connection between the site, the fence, and outside the site, which this is very, very important. Okay, so now let us look at detail 1 and also detail 2. So when we go to sheet number 5, which is the last sheet, you see detail 1. So we have our fence. Okay, so when you cut this detail 1, you see that after some distance you have the internal drain, which is open drain. So this is internal drain, so it's showing it. So look at this line here. This line here is natural ground level. See how it is running? Natural ground level. So this is outside the plant. So and I told you that we raise the facility up. So this is the demonstration, the drawing of how the site is being raised. So we now put the site preparation level. The levels are being labeled very well, and how this place is being sloped. Okay, so see if I finished grade level, see it is higher than the site preparation level by 75 mm. You get, so that is it. What we normally specify for this finishes is maybe some lean concrete and chippings. The concrete there is for anti-weed, so that if you have a plant like this, grasses will not begin to grow in your plant. You get so anti-weed will be there to make sure that grasses don't grow. Then they can now finish it with chippings. Okay. Then after that we have our drainage before we now see the site itself. You get, so you see natural ground level is what this line is showing us. It's not straight. It's not straight. And to get this thing correctly, see what I did. So you just go and cut this thing. Just copy this the way it is. Copy, copy, because I want to show it. Copy, then trim off every other thing. Trim off all this. You get. Then from here, this is my fence. You go and check from the plot plan what's distance from fence to the drain. You get. What is the distance from fence to the drain? The drain, sorry. You now offset that distance. When you have offset the distance, you put your drain to scale. So you see that the natural ground level is already showing you how it is. You don't need to crack your head about that. I've mistakenly deleted the one that is outside the. Okay, this one is excavation. Sorry, so I don't need this excavation. This is natural ground level, and this is how it is going. You get ahead. So that no and still give. You don't need to start plotting anything. You don't need to start. So the line, the finished grade level, the all those other ones are there already. So from here is where you just build up your section and feed those information into bring in here. So that is how it is done. You don't need to start plotting again. Once your plotting here is correct, just come here, copy that section, go to where you want to work on it and trim it. Okay, so see, this is even where I worked on my own. This is it. Get, so this is it. And then I'll put it in my paper space. I'm going to show you how to put joints in paper space. It might not be in this class, but it will be one of my videos. So just stay tuned in this channel. I'm going to be dishing out a whole lot of information here. Okay, so that is detail 1. So if you go to detail 2, it's also showing you how it is done. You have the internal drain, you have some distance which is 0.7 before the fence line, which is block fence. Then you now have a slope, a gentle slope, a very gentle slope. You can see the angle is 15 degrees. So in this particular one, for this particular one, this is natural ground level. You see, natural ground level. So even our foundation for fence is sitting on the field. You get, because we want to raise the facility up. Okay, so you also see detail 4 for the other section and detail detail 3 for the other section and detail 4 for the other section. It's just the same thing. So you can see that this is block 225 block wall. So this is what it is all about. Then here shows the anti-weed specification. So you see site preparation level is here. So we now have 75 millimeter thick granite, you get, so which is called finished grade level. So here now just the granite they are putting here. Then the first layer is 50 thick anti-weed concrete. So they are going to pour the concrete, then they will now put the granite. So this one is well compacted, approved laterite fill material. So for the fill materials, it's going to be well compacted. And then the client has to approve the material for the filling. Okay, so if you can get your site grading drawing to this standard, it is then know that it's generally acceptable in oil and gas. So this is just oil and gas standard. So you just need to take note of all these and try to replicate it in your work. Have idea of what it is to produce a site grading drawing. If you need this particular template the way it is, well positioned in the paper space, just check the comment, no, not the, check the description box for the link to this drawing and just download it. You are going to download it. I have the soft copy, I have the raw file with you, I have the native file with you. So nobody is not going to be just download to your system and you can use it. And for the strength of every civil engineer is what you have in your archive. What amount of information do you have in your archive? So tomorrow, if you become a lead engineer and they ask you to supervise somebody who is supposed to produce a site grading drawing, of course you should be able to know what you should be looking out for. You get so that whenever the person finishes and gives it to you, you know what to check, and how to even check the person's work. Okay, so let me just quickly show us how to like I promised, how to paint those drawings like this one. If you look at the page 1, see that this plot plan is faint. So I'm not actually interested in showing plot plan in this particular drawing. That is the meaning. But I'm showing the side grading. But in my side grading, there is still need for you to have the picture of my plot plan. So, but that's why I superimpose it here. I have to faint it because I'm not showing you plot plan. Well, this is not plot plan. This is side grading, but you should still know how the plot plan is being positioned inside the side grading, the interaction between the plot plan and the side grading. Okay, so that's why I superimpose it there. So it's also recommendable. Okay, so let's quickly do that. This video is already long. Okay, so if I have a line and I want to make it faint, for example, I have this line now. So if I go to my paper space, okay, the line is not even showing. Okay, so it's not showing. Let me check. Okay, it's supposed to be sheet 2. Okay, so this line is here and is very, you can see that the line is very prominent. So now for me to make it that kind of faint that I gave the other plot plan, I will just select it and come to this color. I will choose select color. Okay, so to do that, I will just draw a line. Let me use this line for example. So I'll draw this line. So check. So if I check it from my second page, you see that the line is very prominent. So let me just go and make it faint. So I'll first of all select this line and come to this color. Click on the color and select. Click on select color. Okay. Oh, so nothing is coming out. So here I'm supposed to have some options here from where I will choose what I want to choose. But it's not coming out. This system is asking me to restart. So I can't continue from here. So, but I finished the lesson. So what I will promise you that in our next class, in the next video, I'm going to do it. I'm going to do it in a separate video. I'm going to do it in a separate video. How to convert to how to change how to faint some objects. How to effectively change objects, faint objects. Sorry. Okay, so I promise you, I'm going to do it in our next video, in a separate video rather. So I don't know why it's not giving me. Actually, the system needs to be to be restarted or shut down. That's why it's giving me this issue. Nothing is coming outside. So we'll just end here. And here, this is all about site grading drawing. Like I told you, the first thing we need to do is to request for a site visit so that you appreciate the terrain of the place, and to be able to also compare the topographical data to what you are witnessing on site. Then you also have to know where you are channeling your water, where the access road is. You get then you need to check the spot height very well. If you are raising it up, you determine your design level. You are the designer, you have to determine your design level, but you need to have justification to whatever you are using as design level. Just like I told you, the reason why I raised the site up is because I was told there on site that each time it rains, that the whole place will be flooded. So it's enough reason for me to raise the site up. You get so whatever you are using as your design level, you need to have a backup, a good reason for it, because they will ask you, the client will ask you, why do you choose to raise this site up? Why not use this? Why not use that? You should be able to be strong in your decision and know that you have a substantial backing for your decision. So that when you have determined that, you can now cut your sections, then do your profiling, choose your scale. Normally, I prefer scale 1:1 so that plotting of this profile will not be difficult thing for you. Otherwise, you fall back to the type of scale we used in the secondary school where we did the quadratic equation. The plotting of graphs with quadratic equation. So, but if you use scale 1:1, it's going to give you, it's not going to give you headache. Okay, so when that is done, you can now cut your details and show your details and clearly show how the interaction between the site and outside the site. So that's just all about site grading drawings. Anybody that picks up this drawing should be able to have an idea of how to prepare the site, how to slope, do some slope protection and the rest of them. So we are going to end here. So I will still beg you to give me a thumbs up. Don't just watch this video without liking my video. Like this video, like the video. As you are liking the video, you are supporting me. It's a good support, and I will appreciate that. Also, put down a comment for me. You can just write "well done." It's not easy to sit down here for this is for something minutes and just to give you value. It's not easy. Just give me a thumbs up. Share this content. Subscribe to my video. Just subscribe to my channel and support me. I need support. I need your support through all this liking and subscribing and sharing of my video. Thank you very much, because I know you have actually done that. Thank you, and see you on the next one. Next one, we are going to pick a foundation, either pump or generator or solar slab. We're going to pick any of them and we show us how it is done, what and what to be considered, the loads that are going to be applied, applicable, how to do our load combination, the analysis, what to look out for, the necessary things to be checked, a lot of things. It's going to be quite interesting. Just stay tuned, invite your friends, invite your colleagues. Okay, so we end here. Thank you very much and see you next time.